Bismillahirrahmanirrahim. Assalamualaikum and very good morning. This is BMMU 3764 Bachelor Degree Project 1. The title is Thermal Analysis of Sugarcane Fiber Polyester Aluminium Honeycomb Panel for Hot Humid Climate Application. Before I start, let me introduce myself. My name is Muhammad Irfan Indrawaty. My metric card no B0919102220. My program is 3 BBMMH. My supervisor is Dr. Muhammad Zulkarnain. Introduction. The climate in Malaysia is humid throughout the year. The average daily temperature in Malaysia is between 21 Celsius to 30 Celsius. Typically, wind from the Indian Ocean southwest monsoon occur when May to September, and the South China Sea impact Malaysia climate northeastern monsoon when November to March. It receives around 80% of its annual precipitation, which varies from 2,000 to 2,500 millimeters. According to Malaysia Meteorology Department, Malaysia has been experiencing the southwest monsoon, which has resulted in a hot and dry climate between July and mid-September, with the temperature reaching 35 Celsius to 45 Celsius. According to the Agensi Pengurusan Bencana (NADMA) of Malaysia Peninsula, which has 33 districts in 8 states have been impacted by flooding, which is Perak, Selangor, Kuala Lumpur, Negeri Sembilan, Melaka, Kelantan, Terengganu and Pahang, due to the heavy rain. As we can see in figure 1 show the average temperature and precipitation. And the figure 2 show the flash flood occur at Shah Alam. Okay. Natural fiber. What is the natural fiber? The natural fiber derived from the plant and animal have been used by humans since the start of civilization. Due its low energy usage, minimum material waste, and ease of fabrication of complex components, additive manufacturing has gained prominence as the future standard. Type of the natural plant fiber. We have 5 of the natural plant fiber, which is number 1 is seed fibers. The fiber extract from the seed of the several plant species. Next, we have leaf fiber, the natural fiber that may be extracted from various plant leaves. Example, we have pineapple and banana leaf fibers. Next, we have fruit fiber, the plant fiber extracted from the fruit of the plant. Example, coconut fiber and sugarcane fiber. Next, we have stalk fiber, the natural fiber extracted from the stalk of several plant species, which is wheat straw, bamboo fiber, rice and barley plant stem fiber, and straw are some examples. Bast fiber, the natural fiber derived from the outermost layer of stem. Jute fiber, flax fiber, vine fiber, industrial hemp fiber, cane fiber, rattan fiber, and rami fiber are examples of bast fiber. Due to the robust quality of this fiber, they are commonly utilized in the textile and packaging. Next slide, we can see the figure 3 show the image of natural fiber. We can see the example of flax, knife, jute, hemp, sisal, abaca, banana, pineapple and corn. And the figure 4 shows the sugarcane bagasse fiber. Next, table 1 shows the chemical composition of the sugarcane fiber. As we can see from the table, we have cellulose, which is contribute to 52.42%, and we have hemicellulose 25.8%. We have lignin 21.69%. We have ash 2.73%. And the last one, we have ethanol or dichloromethane extract 1.66%. Next is application of natural fiber. In the construction industry, natural fiber, particularly stained glass fiber, are widely utilized in variety of the building materials. Several sectors, including the automotive and electronic industry, use the cellulose fiber for a variety of purposes, including the automotive and electronic industry. This natural fiber can be utilized to create noise-absorbing panel and insulation. The natural fiber may have medical benefit because they can be used to produce biomaterial. Chitin, for instance, can be utilized to eliminate certain hazards contaminants from industry water outflow. Okay, next slide. Advantage and disadvantage of using natural fiber. Let's go first with the advantage of natural fiber. Which is number one, less specific weight result in higher specific strength and stiffness than glass. Renewable resources, little energy consumption, low carbon dioxide emission, no tool wear, and no skin irritation were observed throughout processing. Little cost production with low investment. It also have excellent electrical resistance, excellent thermal and acoustic insulating, and biodegradable. And we have the also disadvantage of the natural fiber, which is lower strength, especially impact strength, chain quality of affected by weather, insufficient moisture resistance, which promote fiber swelling, minimum permitted processing temperature, reduced durability, lack fire resistant, low weighting with hydrophobic polymer. Okay, this is a literature review. Okay, this is a problem statement. From the problem statement, in Malaysia, we have the heavy rain and it will occur the flash flood. People will losing their house and property. Then we have to placing the victim to a new shelter. On that particular area, there have been a limited capacity at the temporary shelter. So we have to propose a new shelter which meet the convenient to Malaysia hot humid climate application by using of natural fiber, which is sugarcane fiber with composite polyester aluminium, which lead to our objective. Okay, our research objectives to study the thermal analysis of sugarcane fiber and aluminium honeycomb panel and its self properties. To investigate the thermal capacity and the coefficient of heat expansion of combination of material polyester aluminium honeycomb panel and sugarcane fiber. Okay, this is a preparation method. As we can see in the first picture is the mechanical roller. The mechanical roller is used for accepting the sugarcane juice and the waste of the sugarcane fibers. Okay, the next is as we can see the dry sugarcane fiber. The natural sugarcane fiber was immersed in a plain water for 24 hours to eliminate the substance that might affect the mechanical properties, such as oil or sugar. The sugarcane residue is led to under the sun to remove liquid from that residue. And the next picture we have the electronic balancing. We can use the electronic balancing to measure the mass of the sugarcane fiber before we treat with the sodium hydroxide. As we can see, after that we prepare a sodium hydroxide. And next we use the stirring machine. We can use the stirring machine to mix the sugarcane fiber with the polyester resin. And the polyester resin will be mixed with each other by 100 101 ratio. And then we will pour the combination of sugarcane fiber and polyester resin into the mold with the desired shape. And the last one is we can see is the oven. Okay, the last part is we put the sugarcane fiber with polyester aluminum into the inside of the oven to dry it at the 105 Celsius 48 hours. Okay, the characteristic method. We have four characteristic method which is DSC. DSC is mean differential scanning calorimeter. The purpose of this is to determine the phase change temperature and its enthalpies. Next we have TGA. TGA stand to the thermal gravimetric analysis. TGA is refer to the thermal gravimetric analysis to investigate thermal stability. And then we have the thermal cycler to investigate the thermal reliability. The last one we have thermal conductivity analyzer, which is to measure the thermal conductivity. Okay, the expected outcome. The combination of sugarcane fiber and polyester aluminum honeycomb panel with excellent thermal and acoustic insulation, and we creating a shelter with suitable properties of the sugarcane fiber as thermal analysis apply on the composite material polyester aluminum honeycomb panel. And as we can see at the picture below is the cell of the sugarcane fiber with polyester aluminum honeycomb sandwich. That's all from me. Thank you.